It's pretty common to want to copy, construct, or amend the data or structure in a spreadsheet. The API provides many capabilities such as deleting or inserting rows and columns, and then using get or set values to update the data. The problem with that is it can quickly get confusing to keep track of exactly what's where if you've moved columns or rows around. And it can also be pretty slow to keep going backwards and forwards to the API. This screencast will show you how to use the library that I've made publicly available that uses a more declarative and functional approach to reorganizing sheet data. It all happens in memory, so it's fast. And although I'm aiming this at Google Sheet users, it's just array manipulation, so it can be used in any JavaScript context where you want to organize tabular data. So first of all, I'll get some values from a sheet. This is a public spreadsheet containing a data set of the major airports, and it looks like this. So it's got about 1,000 lines in it. As I work through the examples, I'll occasionally want to write the transformed data somewhere. I'd rather write this back to a new place than overwrite the source data. So if you're following along, create your own workbook, grab the sheet name and ID, and get the start range of where to write results out to. So like that, we'll end up with something like fiddle range in this variable here. So here's my empty sheet with my tab set up to receive the test data as we go along. Now I'm using a public apps script library here, see useful. So you can use that, or you can copy the code into your own project from GitHub. The links are in the script file. So there's a reference to the library that I've set up in my resources. So here's how to create a fiddler instance. And I'll add the data taken from the sheet to it. So from now on, we'll access this data through an array of JavaScript objects rather than the array of values. So the column headings are going to be the keys in these objects, and that can be accessed with the getData method. So let's take a look at the first row of that. So here's the result. The first row in my data, instead of just being an array of values, it's actually got some property names which correspond to the column names assigned to each value. So although this is best with data with column headers, it is possible to organize data that doesn't have headers. So in this case, the keys for the data will be the usual A, B, C, and so on column labels. So here's what happens when I set headers off. So now it treated the header row just like any other data row. And then the second element of this array is the first row of data. And you can see that this time the labels that it's been given are the column labels A, B, C, and so on. So setting that back on again, what will happen is that it will just refactor the data back to using the column headers again. So now there's the regular result. It is of course possible to simply modify the data returned by getData, and the changes will be reflected when that gets written back as sheet values. So here's the first couple of lines of the changed data converted to sheet format. This create values method takes the contents of the fiddler and changes it to the format required by the spreadsheet API. It's getting kind of busy in this log file now. So you can see the last one that came out was just an array of values. So each one of these is a row just showing the values, and you can see that it knows it has to put the header out again. So what I did here is I changed the contents of one of the values in the data to something else derived from some other part of the data. This thing here, and put it in brackets and appended it to the original data that we had for that. So the next examples will write the results to a sheet so we can look at what happened in a little more easily than looking at the log file. I'll be doing a lot of examples, so here's a function that takes the data and writes it to a sheet. So it's going to need the fiddler object, which contains the data, and it's going to need the output range, which says where to put it. So this will be in my currently blank sheet, will be my output range, and the fiddler object will be whatever I've done to the data during the examples. Clear the sheet containing the output range. We use the fiddler object to get a range. Given a range that starts at the output range, provide a properly dimensioned one to take account of whether there are headers or not headers in the output data that we're about to create. And then we've used create values before. That just simply takes the fiddler data and translates it back into values appropriate for a spreadsheet to be able to write. Getting back to the examples, but before we start on the real stuff, it is possible to create a fiddler from scratch using an array of JavaScript objects, as in this example. And we'll use that show fiddler function to put the result out to a spreadsheet so we can take a look at it more easily. Let's run that, and there's the sheet it's created. Now I can reset the contents of the fiddler at any time just by giving it some new values. So this is the sheet values that I read in at the very beginning of this examples, and I'm just going to use that to reset back to what it used to be before I played around with it. So let's get to the main purpose of this object now, which is about iteration, filtering, and mapping. So this example will use the filter rows method to select some data. So all these examples will take an argument of an anonymous function, which is the logic that you create to decide whether or not a row should be included. And this function will be called for every row in the data. So all that this function needs to do is to return true or false to either keep or remove that row. So this example will just keep data that's in the US. Note that rows pass to your function, and all the data in each row can be accessed simply by referring to the property which matches the column name. So here's a result. This time we're only seeing airports that are in the US. So between each of these examples, I'll use this set values method to put the data back to its original state, just like this. So you can use that same principle that we use for filter rows to filter out columns. So here I want to get rid of the latitude and longitude column. So I can do that simply by looking at the name of the column. This gets called, by the way, for every column that exists. So I just check the name that's passed. If it's one that I want, I return true. If it's one that I don't want, I return false. Let's run that. So now you see that the latitude and longitude columns have gone. Data can be changed by using the map rows, map columns, map column, and map headers methods. Modifies the municipality column in each row and enriches it with data from somewhere else in the row, and then it returns the row. So typically this row you would just change some properties in it and then return it, but of course you could create an entirely new row if you wanted to replace the one that's there. So let's see what happens. The data in this column has been enriched by adding this stuff at brackets at the end. And map headers can be used to change the name of columns. So here I'm getting rid of the ISO underscore prefix in any column headers that have it. The same principle as before. Whatever's in the first argument, you return it, either changed or not. And here's the columns now without the ISO at the beginning. Now the map columns method can be used to change the values of an entire column. It will call your function for every column in the data. The first argument received by your function is an array of every row value in this column. And the second argument contains some more useful stuff about the data. We'll look at that in some more detail later on. But one of the properties is the name of the current column. So this example detects when it's looking at the elevation feet column and changes all the values to meters. And next it uses the map headers method to change the name of the column. So here we're running through all the values that we received, assuming that the name of the column is the one that we want to do something to. Transform the value from whatever it was from feet to meters essentially. And if it wasn't the column that we're interested in, we just return the values without making any changes. And then when that was finished, we took the result of that, which is, by the way, these fiddler methods always return themselves, so that means you can chain them. We're going to use map headers to change the name of the column, just like we did earlier, changing it from elevation feet to elevation meters, since that's what it now contains. So here we are, elevation feet's gone away, elevation meters is in its place, and the values have all been converted. You can also insert rows and insert columns. This series of examples inserts various numbers of rows at various places in the data. The first argument is the row before which to insert the new row or rows, and the second is the number of rows to insert. Now don't forget that in all these cases the row numbers start at 0, and whether or not you've got headers, it doesn't matter, because it's always referring to the data, not the headers. So the first row of data will always be 0 regardless of whether or not you've got headers. If you don't specify an insert row number value, it will insert it at the end, and if you don't specify a number of rows, it will insert 1. A few blank rows inserted as we wanted. So now we've got these blank rows. Here's how to get rid of them. I'm using map rows, and I'm also using the properties argument to access the values property. So values is an array of every value in this row. I'll only include the row in the data if there is one or more non-blank cell. So this is a case I'm ignoring the row value that's passed to me. That's an object which has properties which correspond to the column names. What I really want is just the values out of that, because that'll make it easier to test. I could have tested the row as well. Handily, the properties contains an array of just values, so I can just run through them and check to make sure that they're all blank. Okay, so our blank rows have gone again. So insert columns is similar to insert rows. So I need to provide the name of the new column, the name of the column to insert it before, and if I don't specify that, it will insert one at the end. Let's see what happens with that. So here's my two new columns, here and here. So moving columns is actually very similar to inserting columns. Just supply the name of the column to move and where to move it before. So here I'm moving latitude degrees to the end, and then I'm moving longitude to just before latitude degrees. So here's these two columns, move to the end and swap positions. Copy columns will take an existing column and copy the contents to a new column with the given name. As usual, the last argument is the name of the column to copy it before. If it's missing, it will copy it to the end. So this example copies the elevation feet column to a new column called elevation meters, and then it uses map column to convert every value in each row of that new column to meters. So map column will call this function for every row in the data, and the value that it will pass is the value of elevation meters in that row, which to start with will have been copied from elevation feet, so it'll still be in feet. So therefore we just simply need to change it by returning its value by that number. Okay, so here's the copy, elevation meters, taken from elevation feet and multiplied by that conversion factor. When we looked at insert rows before, it inserted blank rows. You can also pass some data to it to insert into those rows at the same time. So this extra argument should be an array of objects with as many of the column values as you want to give. So here's a couple of new rows. I only gave the name property, so that's the only thing that's got any data in it. So what that means then is that there's no need for a copy rows method, as you can just use insert rows and pass the slice of get data to copy it. So here I'm inserting a couple of rows at the beginning and duplicating data from the rows that are currently the first two rows. So here we are, the first two rows have been duplicated. You can use the select rows to do a kind of index match VLOOKUP kind of thing. It works a little like filter rows, except it works on a single column, and it will return an array of the row offsets, remember they start at 0, where the match was found. So what constitutes a match is determined by your function, returning true or false. So here I'm returning any row that's in Canada, and here I'm just simply getting the municipality of each one of those rows and logging it out. And here they are. These are all the municipalities in Canada. Now up till now I've only allowed accessing columns by their name, and that's by design to get away from the problems of keeping track of column numbers. It's possible though you might want to insert a column at a specific position, for example to always enter a timestamp in the first column. You can use all the column functions by simply retrieving the name of the column currently at your target position using get headers like this. So this is getting the headers, and it's getting the name of the first header, and it's passing that into insert column, which if you remember needed the name of the column to insert before. And then I'm inserting a timestamp using map column in the newly created first column. So here's the new first column, and there's the timestamp. Now I could go on forever with these examples, so this is going to be the last one. Here I'm going to use the properties argument to do something a little more complicated. So I'm inserting a new column called high before elevation feet. Then I'm using that new column with the map column method. So that means I'll be called for every row in that new column with the value that's currently there. And since I've just inserted that column, it will be blank. So I'm going to go to the elsewhere in the row. I'm going to go to the elevation feet. So essentially what's going to happen is that airports that are really high are going to have really, airports that are quite high, be quite, and not high, going to be not. So this is an example of some of the things you can get from properties. There's a whole bunch of stuff there which you can read up on the documentation that you'll see the link of at the end of this screencast. So here's the new column with the values that are based on the values from a different column. Using this approach makes the whole business of organizing data much less error prone than trying to keep track of where things are. And as a bonus, there's no need for you to use any looping. It's all handled for you. So it leads to a much more functional style. Of course, if you have sheets with formulas, then this may not be for you, since it deals solely in values. But for sheets that are summaries or used as lookups, it's a much handier approach than using the API.